My name is John Wisemantel. I'm the Vice President of Engineering here at Intec Automation, and today we're going to be talking about electronic circuit tester. So this machine is able to be run in a number of different modes and has a number of different functionalities, but at the core is essentially it's testing the continuity, resistance values, and high plot testing of electronic circuits in large flexible or rigid panel arrays of circuits. So the sequence of operations is such that either an upstream process or an operator will load a panel design on the in-feed system. It will be aligned to laser line fiducials. The machine will then take control of the position of that panel with a vacuum conveying system. It will pull that into a predetermined position where we have 4 gantries in this piece of equipment. In one mode, it can be thought of as 2 machines in one, where you have redundant functionality on the left and the right. And in other modes, it can be thought of as additional throughput, where you test some of the circuits in station 1 and then move forward and test the remaining circuits in station 2. The vacuum transport system is very unique. It is comprised of multiple blowers that deliver the negative pressure from that blower up into a honeycomb aluminum panel. And that aluminum panel has a number of holes through its top sheet, as well as a very low friction coating, wrapped in a permeable polystyrene woven belt. And the belt allows a certain amount of flow to be pulled through that belt, which is where you get the hold down force transferring up to the panel, but it still allows the motion of the belt with respect to that vacuum table. The low friction coating allows for both high hold down and very good repeatability in positioning. So any motion of that belt is a direct one-to-one motion of the panel. Moves to a predefined position based on the recipe of that specific panel type. And each gantry can be outfitted with a specific tool. It can be thought of as an end-of-arm tool similar to a robot, but it's a slightly different aspect ratio. It's a long and thin tool that comprises of a number of spring-loaded electronic test pins, and those test pins interact with the panel in certain areas that are specific test points on the circuit. So when we pull that in, you'll notice that the panel is read by a barcode reader to confirm that the panel type matches the recipe that was selected by the operator. Once that's confirmed, it'll pull it the rest of the way in. And then the gantries all have 2 vision systems integrated into their mechanism that are configurable on 20 millimeter increment pitches. And so the machine is set up to be very modular. The way that it's set up right now is for a particular recipe. It has a particular end-of-arm tool put in place, and the cameras are put into position that's very specific to that tool. And so the gantry will move to position those cameras over some regions of interest of the panel, and it'll capture images of the fiducials that are built into that panel. It'll then provide offset distance values to the motion and will measure exactly where the test head or the end-of-arm tool needs to position itself in order to make electrical contact with all of the regions of interest on that panel that are important to run that test. When that gantry comes down, it will engage those spring-loaded pins into the circuit, and that will then invoke a short test run by, in this case, a bank of Vitrec high voltage and high potential switches, as well as a multiplexer that can run through different pre-programmed routines. So the gantries are pretty unique in their mechanical design, in the sense that they have the ability to articulate in a y-axis together by moving synchronously. They can rotate about a theta z axis by varying the y1 and y2 axis. They can move in the z-axis, all servo driven, and they can move in a small stroke plus or minus a small distance in the x-axis. And so the degrees of freedom that you have in each gantry gives it the ability to align the end-of-arm tool to the panel in how that panel is presented to the machine. So if an operator were to set it slightly skewed by a few millimeters, the gantry mechanism can detect that, measure that, and automatically compensate for it, and still put those pins exactly where they need to be within a very tight tolerance. The system in a whole has 24 servo motors. Each gantry has 5. Vacuum conveyors are 2. In-feed, out-feed conveyors are 2 more. So we're very proud of the motion systems that's been designed into this machine. And it's a very robust and a very accurate system. We have the ability to measure and position, and repeatedly put those probes into a grouping that is in the single-digit micron range. So you can imagine that gives you the ability to test circuits that have very small features of regions of interest. And so it's a very versatile machine that can test a wide array of panel types and panel geometries, and really be a modular tool for our end customer to run and expand as they develop different panel designs. This machine can grow with those designs and really test whatever they need to going forward. To talk about some really cool additional mechanisms that are built into the machine, you have a rack and pinion system, which is made by a company called Nexen, and it's the RPS roller system. And this is a zero backlash mechanical interface. It's not like a traditional rack and pinion system that has an inherent amount of lash between the rack and the pinion gear. These are backlash free and have a very precision pitch on the rack itself. And so that contributes to our ability to be able to position each gantry in a very repeatable fashion. Another aspect of the machine that is something that we developed in-house at Intec. Initially, we wanted to search and find a commercially available high-density connector that can be utilized for high pot testing. High pot testing in this device can test up to 6,000 volts DC. And so what we found was the marketplace doesn't have a common product offering, and so we had to design a custom solution. And the custom solution that we came up with is integrated into each test head, and it's a 64-pin density connector that has the ability to test up to 6,000 volts DC. There's over 480 wires that come down from the upper bank of electrical testers down to our gantries. You have 120 cables per gantry, so 120 on the front gantry in Station 1, the rear gantry in Station 1, as well as on the front gantry in Station 2 and the rear gantry in Station 2. And so that gives our customers the ability to test a large number of circuits concurrently at the same time, which results in a high throughput of the equipment. You'll notice the workmanship of not only the mechanical assemblies, but also on the cabling and wiring throughout this machine. That every cable is labeled at both ends, both termination points, with a label that ties directly back to an electrical schematic. So any servicing or diagnosis or debugging is very easy and quick. And you'll notice that the wiring on the machine is such that each wire and the position of those wires in the bundles as they traverse from the device all the way back through energy chains and then down to eventually terminating into an electrical control panel is all very uniform. And so it makes serviceability of the equipment in the future, if you ever need to replace a cable or diagnose a potential cable problem, it makes it very easy to do that.
We can design and adopt this technology to many electrical test applications. Please reach out with your specific manufacturing process needs.